So this is in-class learning for Unit 5, Lesson 1. And so the first thing we're going to do is this is called standard form. And we're going to rewrite this in an equivalent form that's called vertex form. How do we do that? So the very first step is we take the constant and we move it to the other side of the equation, across the equal sign. Opposite of adding 20 is subtracting 20. The second thing we do is we look at the leading coefficient. That is the value in front of the x squared for quadratic equations. If this number is anything other than a positive 1, so that includes a negative 1, if it's any value other than a positive 1, we have to factor it out. What does that look like? We take a 3 and put parentheses behind it. And then I'm going to ask myself, 3 times what value is 3? Easy enough, a 1. Bring down the x squared. 3 times what value is negative 18? Negative 6. Bring down the x. And then you're always going to have a line behind here that we're going to fill in, and it's always going to be plus that value. We'll learn why it's addition in a little bit. We are going to focus in on this trinomial, ignoring everything else to the left. We call this the A, the B, and the C of this trinomial. We're always going to take the B value, and I'm going to highlight it here so it stands out. We take the B value, including the sign, and we're going to always divide it by 2. Always. Put it in parentheses, and then square it. So negative 6 divided by 2 is negative 3. We always take the B value, we include the sign, we always divide it by 2, and always square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Whatever you achieve there goes into this missing spot. Now, you've learned that equations have to be balanced. So, for instance, if we subtract 20 from the right, we must subtract 20 from the left to keep it balanced. I did not just add 9 to the right. It looks like that, but when you distribute, actually, we added 27. So if we added 27 to the right, we must then add 27 to the left. On the left-hand side, combining like terms, 27 and negative 20 is a positive 7. There's a fast way to factor this trinomial. The quick way to factor in it is put an x in front, and then behind the x, whatever is in this last parenthesis gets dropped down. So if this would have been a positive 5, we dropped down a positive 5. If this was a negative 10, we dropped down a negative 10. My last step is to move 7 to the opposite side, so opposite of adding 7 is subtracting 7. When you get to this point, you absolutely must verify that this is in fact equivalent to the equation in standard form and vertex form. So how are we going to do that? Please take your calculator and do second plus 712. If you're watching this video because you're absent in class, then just go ahead and please watch through the video. I'm going to plug in the standard form. And then I'm going to type in the vertex form. You do not want to move beyond this because there's 4 more tasks. You don't want to move beyond this until you verify that these are in fact equivalent. Now, how do we know they're equivalent? We know they're equivalent because when I graph them, you're going to see one function directly on top of the other. There's the blue and there's the red directly on top of it. I'm going to give you an example if they were not. Please watch. If I just change this down below to a plus sign, which is not true, now you can just see an example of where I see one function. Uh-oh, I'm in trouble. Do you see how they're not the same? So I just did that just so that we could see. Okay, we have 4 more tasks after we verify. The first 2 tasks are like 2 seconds each. Please write down vertex, then y-intercept, and x-intercept. The vertex can easily be found in this form of the quadratic equation. Please put a frowning face and a smiley face into the appropriate places. This lies to us this tells us the truth. So the vertex is going to occur at 3, -7. The y-intercept can easily be found in the standard equation by looking at the constant. Now, how do we find the x-intercept? I'm going to show you two methods, and you will decide what method makes most sense to you. One way, you've already learned going back to 8th grade. One way is to take the standard form, where we can see A is 3, B is -18, and C is 20. And I'm going to take those values of 3, -18, and 20, and I'm going to plug them into the quadratic formula. I would like you only to watch right now. If you are live with me in class, just watch. So -18 is my B, 3 is my A, and 20 is my C. Two negatives make a positive. 18 squared is going to be, I think, 324, and I'm right, it's 324. And then I need 12 times 20. So 12 times 20 is 240. So I have to subtract 240 over 6. You are just watching right now. Please pay close attention. So I end up with 84. Now, before I go any further, I have to try to break down that 84 using perfect squares. So let's check here. There's a perfect square. That's not working. So that's 7 squared. Let's do 6 squared. That's not working. Let's do 5 squared. I'm looking for a perfect square that evenly divides into 84. We can see 16 does not work. 9 does not work. Okay, 4 works. So I'm going to break this into 4 times 21. Now, I know that the square root of 4 is 2. Then I need to take and separate the 6 with both. So it has to be shared with the 18 and with the 2. And so I end up with 3 plus or minus 1/3 square root of 21. What you must do now is verify that this is right. Heads up, please. So watch. On your calculator, you're going to do this with me at this time. You must verify, that's what the directions say, using a calculator. I have to see this work, and then you must verify. Here's how you verify. Please do second calculate value. We're going to type in 3 plus, and anytime we use a fraction, we're going to hug it with parentheses. And we can see this equals 0. And now I'll do the exact same thing with subtraction. 3 subtract 1/3 square root of 21. We can see both of them. So this just verified. It works. My preference is not to use the quadratic formula, but you definitely can use that formula. What's some of the other option in order to find the x-intercept algebraically? When we found the y-intercept, notice how x is always 0. And when we find the x-intercept, y is always 0. So I'm going to take the vertex form and replace y with 0. I'd like you to write this down on your paper with me. This is a method you've already learned. So when I go about using the vertex method as a way to find the x-intercepts, I'm going to use PEMDAS backwards. What does that mean? On the side that has the variable, I'm going to ask myself, outside of the parentheses, is there any adding or subtracting that has to be removed? There is. Opposite of subtracting 7 is adding 7. Now, is there any multiplying or dividing? Yeah, there is. Dividing by 3. Is there any exponents? There sure is. This also tells me I'm going to have 2 answers. So on the opposite side, in front of the square root, I'm going to put a plus or minus representing the 2 answers. And lastly, how do I isolate the x? I'm going to add 3 to the opposite side. Whatever you move over last is going to go in front. Now, this could be the exact same x-intercepts, just in a different form, right? It hasn't been rationalized, and I'm okay with that. Well, how do I know if this is correct? I'm going to grab the calculator. I'd like you to do the same with me, and let's check. Second, calculate value. 3 plus the square root of 7/3. It works. Y is 0. Second, calculate. 3 subtract the square root of 7/3. It works. I must see the algebra in order to achieve the x-intercepts, either using the quadratic formula or replacing y with 0 for the vertex method. And then you're going to check here that it is true and it works. Lastly, we are going to graph this. So let me grab graph paper. And I'm going to write down the vertex method. I always want to use the easiest form of an equation. And so for graphing, the vertex form is much easier. Remember, we've already identified the vertex is 3, negative 7. You are welcome to watch. So I'm going to go to the right 3 and down 7. So here is 3, 7. That's my vertex. I can also see that we have a y-intercept at 0, 20. Well, I'm not going to be able to go way up there. That's too far off the graph. In Unit 4, we talked about parent functions. And the parent function for quadratics looked like this. 4, 1, 0, 1, 4. How did I achieve those? Negative 2 squared, negative 1 squared, 0 squared, and so on. We learned, that's how I achieved the vertex, that this value directly in front will always be multiplied by the y's. 3 times 4 is 12. 1 times 3 is 3. How do I use this set of data to accurately graph? This is 0, 0. I'm going to go to the right one and up 3. I'm going to go to the left one and up 3. I'm going to go right 2 and up 12. This is 7, 8, 9, 10, 11, 12. And left 2 and up 12. This is a U shape, not a V shape.